on how it's made. Tissues. Travel trailers. Slippers. And motorcycle helmets. The origins of facial tissue may be Japanese. A 17th century historical account describes people blowing their noses in small soft papers, then throwing them on the ground. Modern-day tissues were first marketed in the early 1920s as a disposable cloth for wiping off cold cream. While some sneezers still prefer traditional cloth handkerchiefs, the disposable paper tissue is the implement of choice with the sniffling and lens cleaning masses. This brand is made entirely of recycled paper, specifically used computer printer paper, because its short, flexible fibers produce soft tissue. The half-ton bales go into a giant machine called the pulper. It breaks up the paper into fibers and mixes them with water. The result is called pulp. Next, it injects the pulp with air. This causes the ink to detach from the fibers and cling to the air bubbles, which rise to the top and drain off. The machine then feeds the now ink-free pulp through several rollers. Like an old-fashioned wringer washing machine, the rollers squeeze out the dirty water. A screw conveyor then breaks up the pulp and moves it to the next station, which rinses it with clean water. Now the pulp is ready to become tissue. That transformation begins in the paper machine. It injects the pulp evenly across a screen conveyor belt. Then the pulp passes through rollers, which press out the water. The extracted water drains down through the screen. The pulp then passes through a hot air dryer and exits the machine as a thin 3-meter wide sheet of paper. Each jumbo roll coming off the machine contains about 60 kilometers of paper. The converting machine is the giant contraption which now transforms this paper into tissues. The first station unwinds 2 rolls of paper, applying modest tension to remove waves and wrinkles. The next station mates the 2 papers, producing a 2-ply sheet. The following station holds the sheet steady with suction, as a knife slices across it every 22 centimeters. You can see the cuts in slow motion. At the next station, these 2-ply sheets meet up with 2-ply sheets coming from the opposite direction. Here's what that looks like in slow motion. And at full speed. The sheets enter a mechanism which folds them in half, in an interlocking fashion. In slow motion, you can see how they interlock. Each sheet folded in half, one side inserted into the fold of the next sheet. This happens at a speed of 16 folds per second. This produces a huge stack of folded tissues, 1.5 meters wide. The next station separates the big stack into small ones in preparation for the final cutting. Each smaller stack contains the precise number of tissues the tissue box will contain, from 80 to 250 sheets, depending on the format they're packaging. The smaller stacks now travel to the next station, where an automated circular saw cuts every 20 centimeters, producing the final tissue size. The interlocking folds ensure that when you pull out one tissue, it draws the next out of the box, ready to use. To produce 3-ply tissues, the converting machine processes 6 rolls into 2 sheets of 3 plies each, then folds them in the same interlocking fashion. The finished tissues travel by conveyor belt to the automated packaging line. A robot with multiple suction-cupped arms grabs flattened boxes one at a time, opens them, and lines them up on another conveyor belt running alongside the tissue belt. An automated arm compresses the tissues and slides them into the box. The next station glues the flaps closed. The top of the box has a removable tab with clear plastic film underneath. A tight slot in the film makes grabbing a single tissue a non-issue. Hitching a travel trailer to your vehicle is the ideal solution if you yearn to travel freely with all the conveniences of home, or love camping, but want far more comfort than a tent has to offer. Today's trailers come equipped with beds, mini kitchen, dinette, toilet, and shower. This 5-meter-long travel trailer is made of aluminum and composite materials. Unlike traditional fiberglass trailers, there's no steel or wood in the structure, so it's resistant to both rot and corrosion. It's ultra-lightweight and has a pop-up roof with windows. The trailer's A-shaped chassis is made entirely of aluminum. The only steel components are the tongue that attaches the trailer to the vehicle's hitch and the axle. Workers insulate both with duct tape. They bolt the axle, with brakes installed, to the chassis, then line the chassis with styrofoam insulation. This prevents the copper propane line from touching the aluminum. Contact between the two metals can trigger corrosion. Next, they mount the trailer's plastic freshwater and wastewater tanks, then glue the aluminum floor to the chassis. Other workers construct the trailer's two sidewalls as a single piece. On a large vacuum press, they spread glue onto an aluminum sheet. Then they lay down the wall's core, a honeycomb-shaped sheet of polypropylene. They coat it with glue, then top it with another sheet of aluminum. The honeycomb core makes the wall rigid while adding minimal weight. They cover this sandwich with a protective fabric sheet, then with an airtight cover. After sealing the perimeter, they vacuum out the air for about 4 hours. This pulls everything tight, compressing the glued layers so that they fully adhere to each other. When the wall comes out of the press, they lay down templates and with a router, cut it into 2 sidewalls. They also make openings for windows. And holes for trailer lights. After inserting a rubber seal in each hole, they install the lights. Next, a porthole-style tinted upper window. They glue it into the round opening, just like a car windshield. The sidewalls are now ready. Workers affix them to the floor with an L-shaped aluminum bracket. Once the walls are up, workers saw out a door opening, then install the door, sliding windows, toilet cabinet, king-size bed, dining table, and kitchen unit, which has a sink and a propane stove. They install a rubber-sealed trap door into an opening in one wall. This gives outside access to a storage area about the size of a large suitcase. Upholstered cushions hide under the seat storage compartments in the dining area. They construct the roof the same way as the walls, only in a teardrop-shaped vacuum press. This aerodynamic shape creates 75% less drag than a traditional box-shaped trailer roof. When the trailer is parked, you can raise the roof to reveal fixed windows on both sides. Workers glue this tinted tempered glass to each aluminum window frame, glue the frames to the roof, then install tail lights, roof vents, and solar panels to recharge the battery powering the lights, vent, and water pump. They install the roof, then mount a hinged back wall. With assembly finally complete, workers apply decals and test all appliances and systems. Cables connect the roof to the back wall, so when the roof lifts, it pulls up the otherwise collapsed wall. The trailer's interior layout is versatile. The king-size bed converts into 2 twin beds, and the dining table can be moved to create 2 distinct dining areas, a 2-seat and a 5-seat dinette. All the comforts and amenities of home on wheels. There's nothing like a pair of slippers to soothe your tired tootsies or warm your frigid feet. Designed strictly for indoor use, slippers typically have a soft sole and looser fit and are made of supple, often cushy materials, so that feet feel comfortable and cozy. This style of slippers is known as Charentaise, named after the region of Charente in southwestern France, where they originated in the 17th century. The slippers are made primarily of felt, which is made from layers of compressed wool fibers. This French slipper factory uses a particularly thick and durable type of felt, composed of 5 wool fiber layers. To cut the soles, workers position a cookie-cutter type die for the specific shoe size in production. Then a 5-ton press forces it through the thick felt. After cutting one sole of the pair, they turn the die in the opposite direction to cut the second sole. Once the batch of soles is cut, they mark the size in ink with a rubber stamp. For the rest of the slipper, called the upper, they use fabric that's felt on the outside, velvet on the inside. The cutting process is the same as for the sole, with the die corresponding to the size in production. Once the uppers are cut, workers lay a stencil of the embroidery pattern on each one and lightly mark the design in pencil. Seamstresses embroider each slipper individually by machine. The yarn is made of hemp. For this model, the design is applied in a chain stitch. Felt flowers give the design three-dimensional features. With the design complete, it's time to stitch the back of the upper closed. Next, they cushion the opening at the top with velvet binding, bending the wide velvet ribbon over the edge of the felt so that the binding runs along both the inside and outside of the slipper. They cover the back seam with a back strap, a felt strip with a loop at the top through which you can put your finger to easily pull the slipper onto your foot. They turn the back of the upper inside out in order to attach the sole. They position the sole 7 millimeters from the bottom edge. Then, with hemp thread, straight stitch along the entire perimeter of the upper. They cut the slipper's insole from a fabric that's felt on one side and velvet on the other. They position the felt side against the felt sole, then sew them together along the perimeter with a particular cross-shaped stitch traditionally used for the charentaise. The insole's felt underside gives the slipper additional rigidity, while the soft velvet surface cushions the bottom of your foot. The slipper is now fully constructed. However, it's inside out. So the next step is to turn the slipper right side out, using this piece of equipment called a goat, perhaps because its shape resembles goat horns. All that manipulation can slightly deform and crease the upper, so they put the slipper in a steam box for 3 minutes to soften the fibers. Then, on a foot-shaped aluminum press, heated to 70 degrees Celsius. The press irons out any remaining wrinkles and resets the shape. This factory's charentaise-style slippers range from conservative to funky. All are designed to be comfortable, cozy, and, as the term slippers implies, easy to slip on or off. The development of the motorcycle helmet happened by accident. In 1935, the British war hero known as Lawrence of Arabia died from a head injury in a motorcycle crash. He wasn't wearing a helmet. The tragedy moved one of his doctors to research the safety potential of motorcycle helmets. The motorcycle helmet is the most important part of the motorcyclist's safety gear. Today, wearing one is a rule of the road in many places around the world. Modern helmets are entirely synthetic. They design them on a computer. The software guides milling tools to produce a prototype from polyurethane foam. The prototype gives them a good look at the helmet's shape and style. Once they're satisfied with it, they build a metal mold for mass production. The molding material is a pile of polycarbonate pellets. It's the same thing used to make astronaut bubble helmets. An injection molding machine melts the pellets and injects them into the two-part helmet mold. The polycarbonate cools and solidifies into the shape of the mold. The result is the outer shell of the helmet, complete with holes for vents and other parts. Next, a robot grips the helmet shell and moves it against a sanding belt to smooth the seam left by the mold. The robot also gives the shell an overall polish. It then goes for a spin as sprayers coat it with black paint. A factory employee pulls a sheet of decals through water to lift them from the backing. She applies the decals to a white unpainted helmet. It's a flashier look than basic black. It takes practice to be able to apply the decals correctly because the helmet surface is complex and curvy. She smooths out air bubbles in preparation for the application of a protective clear coat. The next assembler installs a pivot mechanism on each side of the helmet. They'll enable the face shield and visor to be raised and lowered. The hardware fits perfectly into the molded niches. There's just enough room for the mechanisms to operate smoothly. She attaches the velour-lined chin strap with its quick-release mechanism to the outer shell. Then these foam polystyrene pellets are transformed into the helmet's cushioning inner shell. The pellets flow into another injection molding system. A nozzle injects the melted polystyrene into the mold, and it takes the shape of shock-absorbing helmet liners. The foam solidifies, and the machine ejects the completed liners. The density of the polystyrene foam varies throughout the helmet for strategic shock resistance, enabling it to meet international safety requirements. Padding in the crown and around the chin area makes it more comfortable to wear. They now join the helmet's inner shell to the outer one. After a liberal application of glue, she pushes the liner into the shell. It's a snug fit, and it takes a bit of maneuvering to get it in there. She attaches a robust chin guard to the helmet. This molded polycarbonate part is designed to protect the lower half of the rider's face. The assembler screws it to the helmet on both sides. With this part in place, the rider should be able to take it on the chin if necessary. A transparent polycarbonate face shield completes this motorcycle helmet. And now, a test. They drop a helmet from a height of over 3 meters to confirm it can take a fall without falling apart. It survives, and the entire production batch is approved. Designed for impact and made to specification, this helmet could just save your skull.